Thank you. I appreciate the opportunity to talk today, and for those of you that stuck around here. Permitting new mines in North America is more critical than ever as we look to establish a stable and secure supply of the essential minerals we need for a variety of different industries, right? From technology to defense to renewable energy. The long timelines for advancing these projects certainly challenges this goal. However, there are things that mining companies can do to help shorten the timelines for regulatory review and permitting, and that's what I'm going to spend the next 15 minutes talking about. So we just heard a lot this morning about the really important role that the relationships with the First Nations and the Indigenous communities have towards reaching this goal. That is absolutely critical. And we just heard from the minister about the important things that the government is doing to also help reduce timelines for permitting projects. I want to pivot just a little bit and talk about what mining companies can do in the design process to also help reduce those timelines. Right, so by focusing on sustainable design early on in the process, companies can reduce the risk of having to redo work once the project has started in the environmental or in the permitting process, right? That is a huge cause of delays for a lot of projects. And when I talk about sustainable design, what I'm talking about is developing projects in a way where the environmental impacts are at acceptable levels to various stakeholders, in a way that holistically considers the social, the economic, and the environmental effects of the development for future generations. So there's three different aspects of sustainable design that I want to focus on in the talk today. The first is the importance of starting with a stable project and one that's been informed by a critical issues analysis. Second is really focusing on the alternatives around tailings management and water management. Those are super critical. And then finally, the need to develop a sustainable closure plan early on in the design process. Before I get too far into this, who am I, who is Barr? So as it said in the introduction, I'm a senior hydrogeologist. I've been working for 20 years on developing mining projects in the Great Lakes region, mostly in Minnesota, but throughout North America. Barr Engineering is a 1,000-person employee-owned company. Our Canadian headquarters are in Calgary. Our U.S. headquarters are in Minnesota, just a few hours south of here. And we are a full-service engineering and environmental consulting firm that helps mining clients at all stages of the mine life cycle. So many of you have probably seen this graph that was recently produced by S&P Global. It shows the average time to permit a new mine, right? This includes projects that are in the pipeline and haven't made their way out yet. I don't need to convince anyone in this room that it takes a long time to develop a new project, a new mine in Canada, right? We're only behind Zambia and the US in terms of those timelines. So is this depressing? Is this frustrating? Absolutely. But is it hopeless? No, right? I mean, new projects are able to get through the process. And I think we can do some things when looking at how to design these projects that will help shorten those timelines even further. So the first of those is really to start with a stable project. So what do I mean by a stable project? That's a project description, a narrative that is ready for formal discussion with regulators and the public. And it's one that's been vetted not just for feasibility, but also for permittability, to the point where substantial changes or modifications to the project aren't expected. So we all know that we can't change where the resource is located, and thank goodness, because we've been blessed with a lot of resources in this area. But it's important to take the time early on in the design process to de-risk other aspects of the design, right? And to do that, do so in a way that the project we bring forward into permitting is likely to have that social acceptance, that regulatory approval for the project ahead of time, before starting that process. This needs to be informed by a good understanding of the current and traditional land uses, as well as environmental and socioeconomic constraints. And finally, it has to be informed by engagement with the Indigenous and non-Indigenous communities. So a really good way to get to a stable project is through a critical issues analysis. And so what this is, for those of you that may not be familiar with the term, it really is just a high-level, early effort to identify the sensitive environmental resources, what are the potential impacts to those resources from the project, and how might we mitigate those impacts or reduce those impacts, either through design or through additional mitigation measures. Right, an important part of this is identifying, potential showstoppers for the project. Right, are there landowners that absolutely are a hard no? They're not going to want you going through their property, or are there sensitive species that we really need to make sure we're avoiding those habitats or those areas? The idea is to get started early on in the process on looking at potential impacts of the project and finding ways to reduce those impacts in a way that will make the project acceptable by the regulators, by the communities, once you bring it forward. So I just talked about the idea of doing a critical issues analysis, looking at impacts beforehand. Nowhere is this more important than when we look at how we're going to manage tailings and water. Right? This is critical on all projects in all regions, but especially here, where we have so many water resources that we've been blessed with that we need to protect. So, I have no doubt that just about every project these days does an alternatives analysis when it looks at how it's going to manage tailings on the project. But too often, these analyses are overly focused on NPV. So obviously, NPV is important. Right? Without good NPV, sorry, I get a little tongue-tied, NPV, you don't have a project, right? But likewise, if the project you bring forward isn't going to be operationally feasible, or if it isn't going to be permittable, you also don't have a project. So when you're doing the alternatives analysis for tailings management, it's really important to not make assumptions and to really think through all of the potential impacts for your tailings management facility. So the obvious ones are looking at water quantity and water quality type impacts, absolutely. But we also need to think about energy use and greenhouse gas emissions, right? Dust issues can be huge, particularly when you're looking at dry stack facilities. So what method is going to be best, or maybe the least worse, is really dependent on the specifics of the project, the setting, the regulators. Not all options are going to work for all projects, right? We know that. Slurry basins are still being permitted in Canada. They just have to be done right. And this is where outreach and education plays such an important role in getting approval for projects. Right? Dry stack is trendy, and it's easy for folks to point at your project and say, well, you should do dry stack because that is the best available technology. And sure, geotechnically, it probably is best. But the dust issues are real, and the cost can kill a project, right? So especially if you have a finer grind size. So as you are meeting with your regulators, as you are meeting with your indigenous communities, other stakeholders, really think about how much time and what type of education may be helpful to educate folks, to get them to understand what the various methods are, what are the advantages and what are the disadvantages, and how your project fits into that spectrum. So tailings basins are inherently risky, right? It's important to take the time to de-risk the project early on in the design process in order to avoid that redesign effort that we talked about. So a good way to do that is through the design, but also through adaptive management. I'm going to circle back to the important role adaptive management can play in a minute, but before I move off the slide, I just want to talk about, when we look at tailings management, it is a water management issue, right? These two go hand in glove and really can't be separated. So the way in which tailings are managed has a huge effect on potential water quality and quantity impacts of a project. So let's talk about that for just a little bit further. When it comes to water management, everything is going up, right? There are higher expectations and requirements for mining companies to reduce the impacts of their operations on water resources, whether it be protecting the flows and rivers to protect aquatic biota, or protecting groundwater availability for human consumption, or worrying about the water quality to protect all the things, right? The tightening regulatory requirements results in more water treatment or more water needing to be treated and it needing to be treated to stricter limits. And this is putting a real upward pressure on treatment costs for projects. The upward pressure of costs are somewhat offset by the technological improvements that have taken place in the treatment processes, but without a doubt, cost of water treatment is going up and is becoming really significant for a lot of projects. So the combination of the economical and the environmental and social factors have resulted in increasingly complex water management strategies. And likewise, there's an increasingly expectation for our ability to predict future impacts. Right? The desire to reuse as much mine-impacted water as possible has resulted in water being pumped and moved all around mine sites. This makes changes in the design of one element of your mine project have the potential to impact the impacts of water quality, for example. So changing a grind size can affect the impacts of groundwater down gradient to your tailings storage facility. Everything has become interrelated when it comes to water management at modern mines. And so we need to get more sophisticated in how we look at potential impacts and where in the design process we consider those. So the earlier you can get started in developing your water management strategy, understanding the potential impacts to water and how to mitigate those impacts are going to save you time once you're starting the permitting process. So I mentioned previously, the important role adaptive management plans have in how we manage tailings and water in a sustainable manner. You can see on the slide here some of the advantages of the plans with an overview of the process. The point I want to make here is to encourage folks to get started thinking about adaptive water management early on in the design process. It really helps you understand where are there uncertainties in your water management strategy, in your tailings management strategy, where are there risks, and then what can you do to mitigate those risks. And finally, the last important point I want to make is around sustainable closure. Right? The global mining industry is undergoing a fundamental shift towards a sharper focus on the adequate planning and design for closure and the transition of mine sites, as well as a reconsidering of what sustainable closure even means. So there's a lot of different definitions of what sustainable closure is, but they generally include the following 4 pillars. Right? The first is the need for physical stability. Right? We want to make sure that things don't erode or subside or move from the intended location when we close the site. And equally important is the idea of chemical stability. Right? We want to make sure that chemical constituents that get released from the various project components, that they don't endanger human, wildlife, or environmental health and safety. On top of that is the concept of ecological stability or rehabilitation, right? How can we return the land to a function similar to that prior to disturbance? And then overlying all of that is the concept of socioeconomic transition, right? Is there a way to offset the social and the economic impact of mine closure on the communities, on the workers, on other stakeholders? So robust closure planning really needs to include all of these elements of sustainable closure, and it needs to do so in a way that recognizes that environmental stewardship is more than just minimizing potential impacts. Right? The key here is to figure out what is going to work for the site you have, but also what is going to work for the communities, and then work backwards from there. And to start early on in the process of thinking about what is closure going to look like. One important aspect of closure planning is thinking through the landform design, right? So how are we going to leave the landscape once we've closed the mine? Oftentimes we have kind of traditional closure concepts, such as having wetlands, having uplands and lakes. But is there a way to repurpose that land that will be more beneficial to the communities? The photo here is a mountain bike park that we helped build in an old taconite mine in northern Minnesota. So those are the types of ideas we need to be thinking about early on is there a way to create the landscape so that there's recreational value or agricultural value, or can we develop renewable energy in these areas? So I can see I'm running out of time. I want to leave you with just a few key takeaways for those of you that were maybe multitasking and not listening. The first is that, mining companies have an important role and can positively impact the schedules for permitting. And that's by focusing on sustainable design early on in the design process. It's important to consider environmental impacts at every step of the design process, just as you do NPV and operational considerations. Focus on water and tailings management and how adaptive management can help de-risk the project. And then finally, start with the end in mind, right? Starting with the concept of sustainable closure and working backwards from there. So with that, I don't think I left any time for questions, but I'd be happy to take questions after this session is over. Thank you very much.